I'm back with another one, and this is the final lesson on the series of variation. We're going to look at graphs of variation. So what are we going to learn? We're going to draw and interpret graphs of variation, solve problems involving real life applications. So we'll combine the graphs and the application part of variation. So we straight away dive into graphs of a direct variation. So what are the properties? What are the characteristics? What are we talking about? So the equation of a direct variation, like we had seen in a previous lesson, lesson 1, the equation was y is equal to kx. This graph passes through the origin. This graph passes through the origin. And how does it look? Let me pen which one? Not the red, not the red, not the red. Okay, dark blue. So we said that this one, no Lord, what's that? Eesh. Okay, this is interesting. Okay, all right, so we said that this graph passes through the origin. It's a straight line passing through the origin. What is happening to my numbers? Okay, so we have the y-axis and the x-axis. This graph is y is equal to kx. Of course, we know that k is the gradient of this line. For us to find k, we find the gradient of this wonderful line, and this line passes through the origin. So these are the characteristics of a graph of a direct variation. I think you can see that. So I've already talked about k being equal to the gradient of the graph. We look at the graph of an inverse variation. Characteristics. It is a curve that does not touch either of the axes, more like an asymptote. Asymptotes do not touch the axis. Let's go back. Inverse variation. How does the graph look like? Okay, so we draw the axis. We have the y-axis and we have the x-axis. We are going to have a curve, yes. So this curve will not touch either of the axes, and the equation is y is equal to k over x, like we had talked about previously. Yes. Graphs of a partial variation. We were talking about a partial variation in the last lesson. Check it out if you haven't. We said that this type of graph has an equation of the form y is equal to kx plus b. No, it's not k. Yes, it is k. We can put a k or m there. I know in the previous one we had y is equal to mx plus b. M gradient, k constant of variation. K is equal to m. So k is the gradient. That's what we said. B is the fixed part, which is the y-intercept. So the graph of the partial variation, let me rub out that stuff. Okay, so Mr. Rubber is at work. Okay, so what are we saying in the second point? We're saying it does not pass through the origin. This is what's supposed to be rammed into our brains. This is what's supposed to be in our brains. We're saying if we're looking at the partial variation, it should not pass through the origin. If it's passing through the origin, we're talking about the graph of a direct variation. So K is equal to the gradient of the graph. B is equal to the y-intercept. How does this graph look like? Okay, so if it's not passing through, it's a straight line that is not passing through the origin, this is what we expect to see. We'll have a point there. So this is B. Then this equation, the equation will be y is equal to mx plus b. So this is what we are dealing with when we're talking about partial variations. Okay, an example. So this example is going to combine the knowledge that we have gained in the previous lessons with the application of this stuff in the real world. So when you look at the graph alongside, we have voltage as in the vertical axis and current in the horizontal axis. We have a straight line graph there. Wonderful. Okay, so we need to answer the following questions. So I'll read the question real quick. So the graph alongside shows the relationship between voltage and the current of an electric circuit. What kind of a, part A is asking us what kind of a variation does the graph represent? B, find K, the constant of variation. C, determine the equation for the situation. Then D, calculate the value of I if V is 22 volts. Pause the video, try and look at this on your own and see whether you can sort it out. Let's start with part A. I'll write part A just on top there. What kind of a variation does a graph represent? When you look at this graph, the graph is passing through the origin. The straight line is passing through the origin. Therefore, it is a direct variation. Part B, find K. We know that K is the gradient. So change in y over change in x. So what we're saying is y2 minus y1 over x subscript 2 minus x subscript 1. We need to pick 2 points on this graph such that we assign them these values. I'm going to pick points that will not cause me problems to identify. So we have the first point, which is 4, 6. 4 is the x coordinate, 6 is the y coordinate. And I'm going to pick 8, 12. 8 is the x coordinate and y is the y coordinate. 12 is the y coordinate. So what do we do there? We assign. So I'm going to assign I'm assigning this one as my x2, x subscript 2, y subscript 2, x subscript 1, and y subscript 1. Let's get back to our sweet color. So we'll say 12 minus 6 over 8 minus 4. That will be a 6 over 4. In its lowest terms, this can be represented as, what is that? Oh no! Okay. Let me assign nice blue. So when we take this to its lowest terms, it's going to be, we'll say, we'll reduce it and say 3 over 2, because we factor out a 2 from there and we factor out a 2 from there. 6 divided by 2 is 3, 4 divided by 2 is 2. So our k will be 3 over 2. Let's look at C. Since this is a direct variation, the equation will be y is equal to kx. But for this particular one, this is a general thing. For this particular one, we've already found k. So this will be our equation. So this equation is our model. Let me write part D right here on top. We have a model there. Determine the equation for this, for the situation. In fact, we're not done. Why am I rushing? Why am I rushing? I should not rush. Okay. So we have found a general equation for this situation, but for this particular situation, our vertical axis is voltage. So y will be V, and x, the horizontal axis is I, which is the current. So for this particular situation, V will be equal to 3 over 2 I. Wonderful. Calculate the value of I if V is 22 volts. That is what we are going to look at in part D. So where there is V, we're going to put 22 because we have been told that this situation has 22 volts. We need to find what I is. So we have 3I over 2. So we cross multiply, we'll have 3I being equal to 44. So our I, the current, we divide both sides by 3 and we'll have 44 over 3. I don't know if it's amperes or amps. This can be written in mixed number form as 1. 3 in 4 is 1, remainder 1. 3 in that is 4, remainder 2 over 3 amperes. Okay, so that is how we sort this question out. So this is our result. So what are we saying? So we have created a model in part C that will help us to solve any problems. Any voltage that is not on the graph can be sorted out. Like 22 volts is not on this graph. So we substitute it in there, and that is how this lesson ends. So we have looked at variation and the series of lessons pertaining to variation has come to an end. You can share this video, you can like, you can subscribe, and have a wonderful day.